Alright guys, so in the last video we kind of talked about the relationship between inflection points and concavity. We said that inflection point happens when the graph changes concavity, either goes from concave up to concave down, or the slope increases to where the slope starts to decrease, or vice versa. So now let's take a look at an example of how we can algebraically use the second derivative to find a specific point of inflection. So let's say we want to find all of the inflections of a particular graph. So find all points of inflection of the graph y equals e to the negative x squared. And so kind of thinking for what we're going to find a point of inflection, let's kind of recap a little bit. We know that we're going to find a point of inflection when the first derivative, y prime, has a local min or local max, or when the second derivative equals 0. And so we're going to kind of use that second point of things as to when are we going to specifically see y double prime equaling 0 in this case. So let's first and foremost find out what y double prime is. So y prime in this case, don't forget, remember, any e function, e to the x derivative is e to the x. We have to kind of take into account the specifics between what's happening inside of that e to the x function. So e to the negative x squared stays the same. Then you got to multiply it by the inside function using our chain rule. So negative 2x, because the derivative of negative x squared is negative 2x. And then we need to take it one step further to find out what y double prime is. And so now we have the product rule happening. So we have e to the negative x squared being multiplied by negative 2x. So now we have a product rule. So now we take the derivative of the first function, the derivative of the first function, so e to the negative x squared stays the same, multiply it by negative 2x, because that's the derivative of negative x squared, and then multiply it by the second function, which was also negative 2x. And then we add it to the first function times the derivative of the second function, so times negative 2. So just kind of simplifying this all out together, we see that the second derivative is e to the negative x squared being multiplied by 4x squared minus 2. And I just factored this out just so we can kind of see a little bit easier when this is going to be equaling 0. So our goal here is to find out when will this equal 0. So e to the negative x squared times 4x squared minus 2 equal to 0. Well, just like in any other thing, we would set both factors equal to 0. So e to the negative x squared equals 0, and then 4x squared minus 2 equals 0. Well, one thing we have to know about the exponential function is that e to the negative x squared is always going to be positive in this case because it is a squared function that we are dealing with. And so now we need to figure out really when is 4x squared minus 2 going to equal 0, because that's what's going to cause our entire function to be 0 as well. So we have x squared, 4x squared equals 2. Dividing by 4 on both sides, we get x squared equals 1/2. And then x equals plus or minus the square root of 1/2. And so we know that we are going to specifically see a change of concavity happening when x is equal to positive square root of 1/2 and negative 1 square root of 1/2, because that will make the entire function 0. So specifically, a point of inflection at x equals square root of 1/2 and x equals negative square root of 1/2. And then if it does ask you to take it one step further to find the entire ordered pair, you would just substitute the square root of negative or square root of 1/2 or negative square root of 1/2 into your original function. And in this case, you see that f of the square root of 1/2 is going to get us 1 over the square root of e. And then also, when you do the exact same thing for the square root of 1/2, taking the negative of it, you also see that it equals 1 over the square root of e. All right, guys, so that's going to wrap it up for this particular example. We're going to give you an exercise to give a shot on your own. This one's going to be on page 215 in your book. It's actually going to be number 13. It's going to be the exact same thing. Find all the points of inflection. It's going to be find the points of inflection for y equals x times e to the x. And your answer to check is going to be -2 comma -2 over e squared. So give this one a shot on your own, guys, and we'll check over it first thing when we get to it.